Welcome back, everybody, to the second day of AMP Camp. So before we get started, I'm going to just have a couple of announcements to share with you. I want to cover a quick overview of what today has in store for us. So yesterday was kind of a beginning to end sampling of the badass stack, including exercises at the end that most of you were able to participate in, that walked you through command line prompt, data analytics, to machine learning with k-means on top of Spark. Today is going to be more a la carte, and it's exciting because it's an opportunity for the lab to show you the next things that are staged to be more fully integrated into the pipeline or into the stack. So as you know, and as you've seen in the text around the AMP camp, the AMP lab is focused at the intersection of crowdsourcing, cloud, and algorithms. And so Tim is going to talk in a second about crowdsourcing, and later today we'll have other talks about user applications of the AMMP synergy from AMP. Mateo, so in addition to kind of the other things happening in the lab that are exciting, we'll be covering a couple of advanced features in Spark that are either in alpha or pre-release right now, including Mateo's talk on just more advanced Spark features, Josh's talk on the upcoming Python API, which is unreleased, TD's talk on streaming, Spark streaming, which is going to be released in the next couple months, and then Ben Hanman's talk on the exciting news about where Mesos stands inside of Twitter in production, running on over 1,000 nodes, running production services. Adam will talk about collaborative energy debugging with Carrot, a mobile application. And then in the user applications talk, specifically we have people from Conviva, Quantifind, and Mobile Millennium. And these are all real applications with real users who have people with pagers that go off when some component of the badass stack that they're using doesn't work, which, as far as we can tell, and they'll tell you, is not very frequently. And then Mike will wrap up. So as I said yesterday, and as you've seen throughout, we really do have a focus with the badass stack on practitioners. And being very early in the project, we have a few years of runway to get it right with your feedback. So this was hopefully the first of multiple AMP camps. And what we'd like from you, if you look on Piazza, we've posted a poll in which you can give us direct feedback, and which it should show your feedback to the rest of the community, because part of building this open source stack is you all participating as the community around the momentum that we, together with the UCB backing us, can carry forward. So the questions that we've asked in this poll on Piazza are things like, what are the data types? What sort of big data are you using? What are your current solutions? Where are the pain points in those current solutions, whether they be the components of the badass stack or otherwise? And how can we help solve those pain points? And how can we as a community all make a strategy for solving those with the resources of the AMP lab leading the way on the badass stack? So please, it's really valuable to us if you take a second to share those thoughts about your current production needs. And if you have more sensitive things that you're not comfortable sharing in an open forum, we've got a link to a private Google form on there that you can share things, and that will be kept confidential within the leadership of the lab, and believe us that you can have a very meaningful impact on the direction and the vision of the lab, just providing us with real insights into the applications that you're solving or the applications that you're using the badass stack for. And then more about logistics, we'll give you another form later in the day where you can just give us straight feedback about how this event was. It was the first event, And as far as I know, the first event that is precisely of this kind, with a very large, very academic research lab engaging the open source community to try and provide a stack that they use in a very relevant way, and where the community can have feedback early on in the project. So we valued your saying, you know, at the next AMP camp, the exercise session should be longer, or should have these types of questions, or shouldn't have an exercise session. And we'll give you a form where you can give more specific details about AMP camp later today. So without more announcements, I'd like to introduce Tim Kraska, who is a postdoc currently in the AMP lab working with Mike Franklin. He will be starting as a professor at Brown in January, and he's been focused on crowd applications and crowdsourcing, as well as just database research in general.
Yeah, thank you. So yesterday we heard like a lot about the machines and algorithm part, like how to use, for example, Spark to write your algorithms, how to use Mesos to really like enable all the machines in a cluster. However, there's like one letter missing in AMP, and that's the P, the people part. Right? Because like we in the AMP lab believe that you tightly need to integrate algorithms, machines, and people to really make sense of data at scale. And this is like a brief overview about this vision, like what techniques we are using in this regard and what we are thinking of. So Ariel actually described yesterday this workflow of like how to build a classifier. Like in the beginning, you have a full data set, you split it up into a training and a test data set, and then you use this data to train your model, test it, and in the end have your classifier to classify new data. However, what you need here in the beginning, and what you didn't really talk about, is you need the email in the raw format, but you need also like the training set. So somebody needs to say, this email is spam, this email isn't, in the first place in order to train the classifier. Right? You need like something to seed this whole process. And normally, like people have to step in at least for the seeding part, right? To figure out in the first place, like what is spam, what isn't, so that the machine learning algorithm actually can learn this behavior, and then that you have this classifier in the end. However, this is like already a quite advanced kind of example, in particular for this machine learning case. But there are like even simpler cases. For example, here we are just trying to figure out a picture, what is a dog, and humans are simply just better in that. And even if you would have like a really sophisticated machine learning algorithm, I doubt that it will ever be able to identify what the thing here in the middle is, a cat or a dog. Right? So humans are actually quite useful in many, many scenarios. And that is like throughout the whole data analytics pipeline. And they can help and like enhance existing techniques, algorithms, to get like more value out of it. So humans can be used like for data collection, like really trying to get like new data corpora in, or enhancing existing data, for example, providing this label or not label. You can use or leverage them for data cleaning tasks. Transcription tasks are quite often done, or like more creative things, like what is a better picture for something, right? Or like coming up with creative solutions. So now, I would just like to give you like a brief idea like how people nowadays already use this like people resource. And there are like a couple of really nice examples out there. For example, Galaxy Zoo. Has anybody heard of Galaxy Zoo here? Not many. So Galaxy Zoo is like, it's designed as a game, and like what scientists do there, they post like satellite images of the galaxy, and then they ask people to identify galaxies. Right? Essentially, they explain how they look like, they give some examples, and then they leverage people actually like on this platform to identify new galaxies. And this has like two purposes. First of all, like just by providing this game and you get like some points if you identify a galaxy correctly and so on, they get a bigger data corpora about like new galaxies and how they look like. And they can again use this data set actually to train machine learning algorithms to automatically identify galaxies. So it's like a really powerful tool. Another example which I also really like is Folded. It's another game where you are trained to do protein foldings. and you get like points for how good you make the folding. And it turned out to be that like humans are way better in particular complex structures to figure out the right folding of the protein, and they can outperform existing algorithms actually by quite a bit. So this is like a game 3D game, and again you get points for it, and on the side you're creating new data, new folds, and that again can be used like in order to train machine learning algorithms and work as a data set as well. However, there are like very simpler cases, for example Stack Overflow, like most people probably know here. Right? It creates a knowledge base for bugs. Right? So like if you have a problem with some development tools, it's pretty likely by now that you find a solution on there. So it's a really like interesting way on how to create like a knowledge base. And then there are like other not so well-known platforms. Freebase is one of them. It's essentially like trying to outsource structured tables. So people can create a table there, put data in, for example, all the states and like with the population for each state and so on. And those tables are provided in a structured format and can be used by other people. So it's like a really nice platform actually to get like an initial data set and just grab it from there. And of course you can also use it automatically, and people contribute to it, correct errors and so on. So I think these like few examples already show like the power of people, what they're actually able to do. But how to leverage them as a developer? So crowdsourcing for developers 101. So the first thing you need is actually a crowd. Right? And then what we developers normally do is we wrap them around an API so that we don't have to deal with them anymore. Just have like simple message invocations to some API, and we let the machines talk to it. Right? That's like the typical way on how developers think about that problem. And of course, it's a bit hard because you need the crowds in the first place, but luckily there are already platforms out there which essentially deliver exactly that, an API around the crowd. And the most famous one currently is Amazon Mechanical Turk. Just by a show of hands, how many people know about Amazon Mechanical Turk? Oh, the word is spreading. That's great. So, so Amazon Mechanical Turk is the marketplace for microtasks, right? So you can like post a task there. It's like normally really like little work unit, for example, like asking for what is inside an image, and then somebody can type in what is inside the image, and you can collect the answer from it. Right? The interesting part of this platform is it offers a web service API to it. So you can automatically post this like task on this platform, and normally you have to pay like some cents for it. The minimum price is 1 cent. And then you can collect these answers automatically from this resource. So by doing it, by wrapping this API around that, you can automatically now post tasks on this platform and collect the answers from it. And people worldwide are working on this task and like trying to figure out an answer from them. Actually, what you are doing is you are turning like humans to a resource. Right? So now machines can ask humans questions and automatically collect the answer from them. And what we are doing as part of the AMPLab is like using this new resource as well. So just to give you an idea, like for the people who haven't seen it yet, this is like the Amazon Mechanical Turk marketplace. That's the platform. So you see like a couple of tasks on it. You can click on one. This is like one of the tasks we posted at some point. So it's just asking, is this guy here on the right the same as the guy here on the left? There are two database professors. They look a bit alike, but not really. So you just click yes or no. You submit. And then the answer is submitted to the system. And this is just like the interface for it. So this is like crowd equals says no. So the two people are not the same. And you just can collect the answer from it. Right? So it's a really simple platform for it. Amazon Mechanical Turk is not the only one offering that. There are others. Zamasource is one of them. They have a bit more controlled environment. MobileWorks is actually a startup here at UC Berkeley doing exactly the same thing as well, and with some additional support like features, but essentially the idea is the same. So we have this new cool resource we can use, and they are like pretty powerful. Humans in general, the capabilities of humans is a really powerful resource. However, there are some issues with it. So first of all, this like new CPU units, people have like a problem with quality, right? It varies way more than what you normally get from a CPU. Second, you have to program them in a really funny way with user interfaces. That's like something we are normally as programmers are not really used to because we give imperative instructions. You can still try to do that here, but it might not really totally work out. Right? So user interfaces is like the way of programming it. And then there are like all these other issues you suddenly have to deal with, like worker motivation, how to compose your task in the right form, how to leverage the worker individual knowledge in the best way, how to optimize, like for example, time or cost, and there are like different ways. If your goal is time, you would do it differently. If your optimization goal is cost, and so on. So the thing which we at least get asked the most is like how we deal with this first bullet point here, quality. Right? So the rest is just like normally if you post something, it will work, but the quality issue is really fundamental. And you post a question, you get something back, a random person is working for you. So how do you know that the person is not scamming you? And I just would like for this first part, like the question, how can you trust this crowd, the people out there, show you like a few techniques on how to deal with it so that you get an idea what we are doing. So there are like a whole bunch of techniques proposed. I just listed a few here, approval rate, goal set, random scenes. And in particular, I will only talk about the first three because they are like the most common one used. So the first one is called the approval rate. It's a pretty simple idea. So every worker on Mechanical Turk has like a score. And the score tells you how many hits he got successfully accepted, meaning for how many hits he got paid. And how often did like a requester, so somebody who like was posting the task, the first one said, no, that wasn't correct. I don't pay you, I reject your answer. Right? So it's essentially just like a percentage, how often got he paid. So it sounds like a great idea, right? It's just like, okay, every worker has the score, and I only accept like workers which have a score, for example, of 95%, because that are high quality workers. It's really easy to set up, it's transparent. Unfortunately, it's easy to defeat, and by now, this measure is totally meaningless. And the problem is that people like care so much about the score, they complain a lot if you reject a hit. And that is just like one of the complaints we got at some point. He did like 290 hits for us. 11 of them were rejected because we detected they are wrong, right? And he goes just nuts. And now you have to think about it. He's complaining and about 11 cents, right? For him, that might be a lot of money. For us, it's like 11 cents is not so much. And you have to think about how much time you want to spend to justify the 11 cents, right? So it takes a lot of time to actually engage in this case, because like in the moment you wouldn't answer at all. The poster goes like to forums, complaints about you. So it's like really important that you interact with them, but it's like it's actually a lot of work. So what most people, including we by now, ended up with is essentially saying we always pay. Right? So we use other techniques. We always pay regardless what he is doing. And therefore, this whole measure of the success rate becomes completely meaningless because almost everybody is doing it. So most Turkers by now have really, really high scores, and it says nothing about like how successful they actually are. Now, often you know, as a repeater, the question was essentially like, how do we know when to reject the task if we don't know the answer in the first place? And so it's essentially like, so in order to reject, we need to know what is correct, right? And that is only possible if we know the correct answer, apparently, so we wouldn't use crowdsourcing in that place at all. But let's assume we use like other techniques as well, right, to figure out, okay, what is the correct answer, and I will show you some of them. Right.
Because in the past, like we had UseAFT, and the problem was the outputs was very noisy.
Mm-hmm.
Like, I mean, there's a lot of like false positives and whatever. So
Exactly, that is what we're also using. That's like the most common one is like redundancy, and I have a single slide on that.
Do you think that Amazon could fix this problem by just always paying, but still keeping the accept reject score available as a metric?
Probably, yeah.
Yeah, that would fix it.
That would fix it, yeah. I would say, yeah, if you mark them, but let's, because like then, yeah, sorry, I need to repeat the question. Right. So the question here was just like if Amazon could fix the problem just by like essentially memorizing internally what was rejected and what wasn't, but still always pay. And probably that's like one way around it, yeah. Okay, another pretty common technique, really successful to figure out like bad workers or not, are gold sets or honeypots. So that is essentially just like injecting from time to time a question where you know the answer for. And that are like trap questions, and in the moment a worker is doing them and he provides us, the wrong answer, you know, oh, maybe something is wrong with him. So you can mark him, and you can actually also use it as a training tool. It's very effective, very cost efficient. At the same time, like trying to dig this gold, again, the same question, like figuring out, as before, like figuring out the right data in the first place to do that, it's a tough problem. And in addition, you also, like people often recognize after a while what the goal is. I think like many people here might know reCAPTCHA. So if you look at enough examples, you figure out, for example, that the data can be numbers or like something with special characters, and the gold is always the honey. Right? So if you want to like bypass reCAPTCHA, the only thing you need to enter is actually the honey part, and the data part they don't know. Right? So for example, if you have a reCAPTCHA number and something else, always just type the something else in there because the number is most likely to be something reCAPTCHA also doesn't know the answer for. They are trying to crowdsource. So there's a training effect. And last but not least, the most common one in order to like clean data is just like using replication. So instead of asking like the question just once, you ask it a couple of times, and then you take the majority answer, for example, as like the final result of it. It's again, it's easy to implement. It's hard to defeat because you can, the system can ensure that like a single worker is never doing the same task again, so that like different people are working for you. It's actually really simple and powerful technique. And there are like many extensions to it. For example, you can like increase the Chrome, like depending on how like variable the answer is, and you can play around with biases and so on. There's like a really powerful technique which I extended already in like various ways. So this is just like to give you a brief idea, okay, what are the different quality control techniques for the crowd, what we can do. And there are like many, many other issues out there. Like for user interfaces, there are many ways on how you design a user interface, how to motivate the worker, how to do task decomposition, and so on. So overall, you have like a lot of different ways on how to achieve a task, which have like all implications on quality, cost, and time. And this creates a big, huge space, and that's something we're trying to simplify a bit with CrowdDB. So in a certain way, like yesterday, you heard about Spark, which like provides really like this low-level like primitives, which you have to combine in order to create like an analytical task. But you also heard about Shark, which sits on top of it and lets you express something in SQL, right, which is compiled down to then Spark, like hides all the primitives away. It makes it way easier, right? You have this like higher level language. And that's exactly what we are doing for CrowdDB here, for crowdsourcing. Right? CrowdDB actually offers as well a SQL kind of interface, which is then compiled down to like operations which potentially go out to the crowd. And we do that for a certain domain of task. Remember the thing I showed you in the beginning, for example, like what is inside those pictures? Those are like the types of tasks we are concerned about. Like everything which has to do, for example, with data collection, data cleaning, entity resolution. So now I would just like to give you a brief overview on how, like, what CrowdDB is, what it does, and like what are some of the techniques, insights on how we use them. So CrowdDB is essentially like designed along the lines of a traditional database system. So you have like the typical stack of parser, optimizer, executor, and so on. But now in addition, we also have the crowd as a resource down there. So whenever we cannot answer something like with the stored data, normally we try to go out to the crowd automatically to require the missing pieces, the missing information. In order to specify when to use them, we have like a little extension to SQL called CrowdSQL, which lets the user or the developer specify when to engage the crowd and for which type of task. And then, of course, we have like all this machinery in order to like really place the task on the platforms, collect the answers from it, do some quality control with them, like take care of the workers, like the usual stuff you need to do in order to interact with the crowd. Okay, so for CrowdSQL, just to give you an idea how this language looks like, so one thing we allow you to do is essentially like mark an attribute of a table as crowdsourced. So for example, this one is just saying, okay, we have companies with names, but maybe I'm missing some of the addresses. So whenever I now would look for an address, it would actually automatically go out to the crowd to figure out the missing address, like if it's not there in place. This could be also used like for this, like labeling, for example, the mails. So we could have a table with mails, and then the label would be a crowd attribute and saying, okay, whenever we are missing the label, if this like mail is spam or not, we go out to the crowd, ask for the missing label, and somebody would provide it to us. However, we also allow to define whole tables as crowdsourced. And you do that by just like putting a crowd keyword in front of the table definition. That means that whole entities can be missing. For example, we could have a table about like green tech companies in the Bay Area. And if you now do a select star on it, it tries to figure out all the green tech companies in the Bay Area. And it has some issues, so I come to that in a second, how to deal with like these open tables. And then we have like two extensions to the data manipulation language of SQL. One is that we allow like fuzzy comparisons down here. Fuzzy comparisons is essentially saying, okay, I'm looking for something as like which is referred to as big blue in this case, but it doesn't have to be stored exactly like that in the database, right? And big blue referring to IBM or International Business Machines, and the system is trying to do this like fuzzy comparison of it. And last but not least, we have higher ordered functions like crowd order, which is like using the crowd, for example, to establish an ordership between the quality of pictures or like something which is better represented. So what's happening in the background then is we take this SQL expression, and here it's just like a really simple case where we have two tables, one is professors, one is department, and we do a join between them, select from professor and department, and use for and look for the professor named Michael J. Curry. And so like we want to have the department as well as the professor information of this professor Michael J. Curry. So this is translated into a relational algebra query or plan. Like that's the normal thing databases do without like showing you all the details. And then this plan is like actually like creates the user interfaces in the background. Now the interesting part is because we have like this task decomposition, we use this declarative approach for doing it. There are like different ways on how to ask the same question. So for example, we could ask for the department information first on the crowd and then for the professor. We could ask for the professor first and then for the department information for this professor. Or we could ask like for everything combined together. Like there are different ways now because we have this plan how to execute it. And that is something the optimizer, at least we envision it, to pick automatically at some point for you. And in this particular case, we actually ran this query. Like this first one is completely inefficient. It doesn't work at all. The reason behind it is that like if you are looking for a specific professor, how do you know in which department he is in? So what you would need to do is like first figure out all the departments, in the worst case worldwide, and then you figure out in which professor actually like which department it is the professor is in. The other one actually works pretty good, so asking for the professor first and then the department information. And the last one, the combined one, we always thought it's like the best case. It actually decreases the quality of the answer. So the combined one is just like asking for the department and professor information at the same time. And the reason what's happening here in the last case is that because you show everything in a single interface, people got confused that we are looking for the department phone number and not the professor phone number. So like what they always typed in was the professor phone number and not the department phone number anymore. If you separate the two concerns, actually the quality was just fine because it was a more specific question and there was less confusion going on. And the moment you combine it, it created some problems. So this is like what's happening in CrowdDB under the hood, the optimization process. But there's even like a way bigger question. Just because now we have this new resource in place, actually we changed one of the most important assumptions of a typical data management system. And that's called the closed world assumption. Closed world means like a normal database assumes like whatever is stored inside the table or inside the database is the whole world. There's nothing outside. So every answer is well defined. It always, like every query exactly produces always the same answer and so on. And the moment we include now crowdsourcing, the world becomes open. Right? Because there's always a chance that we can acquire more data. So just to give you an example, how would a query or like the answer should like for a query like select count from ice cream flavors, where ice cream flavors is one of these crowd tables, where we go out to the crowd to find more ice cream flavors. And so how do we know the answer is complete? When are we done? And this query would actually run on our platform. It would create a hit. It would post it. It would spend money on it. But it's like really hard to access now what's the quality of the answer, right? When are we done? So let me show you a bit simpler case. Select star from US states. So at least we know what the answer should be, how many states are out there. But like, how does the system know it? And you might think there's almost no hope for it, but that's not essentially like totally true. If you post this task on the platform, what's happening is like over time, so that is the answers over time, you see like more and more states coming in, and at some point at 50, of course, this leverages out, then you have all the answers. So you get this like curve over time, right? Over time, you get more and more states, and at some point you have them all, and there are no more coming in. And this problem to estimate, okay, like how many states are actually out there is something like biologists already do for quite some time for species estimation. So what they are doing is just like going out in the wilderness, catching animals. Based on the caught animals, they are trying to predict how many species are out there. So we are trying to provide like completeness estimations by catching answers. And based on our caught answers, we are trying to estimate how many unique answers might be there out there. So we are leveraging these techniques now in order to provide like some quality estimation about the result set in CrowdDB. And that also works like for the US states kind of well. Here like two techniques we developed for set size estimation here on the right. And what you see is like over time again the numbers of responses at some point it's like stabilizes really around 50. And that's like the estimation we would give out. So coming back to the case what we had before with the ice cream flavors, if you would run the estimators here on the right, they're always going up because ice cream flavors, the problem with ice cream flavors is that there's always a chance that you find another one you haven't seen yet. Right? So, and like if we ran this task and you get more and more, and there are like many cases like that where it's like, it's a really huge, large set, which is skewed distribution, so there are many rare items, and it's like really hard to get it entirely. And of course, our techniques can also not like provide some magic there. There's like this famous quote from one of the people working on this estimators for a long time good. He's believing that it's like impossible to really precisely estimate species because there's always a slight chance that there's like something else out there, right? For example, if we would run a query like getting all the elements in the universe, still we might get like all the answers back which are on Wikipedia, but it doesn't mean that there are not more out there and we simply don't know about it, right? So it's like a really fundamental issue. However, what we can do instead in this case is we can ask, okay, how much more money would like, for example, $1 or $2, how much more value would like $2 give us? Right? So like how many more answers would we get in? And again, we use like ideas from species estimation to do that. So for example, we can estimate, okay, if you would post another 50 hits, how many like new answers could you expect from the crowd providing you? And again, this is like to make this trade-off between like the benefit and the cost of posting like new hits on the platform. So last but not least, one note on like another technique that we are exploring like more recently as part of CrowdDB in this whole setup is like this combination of machine learning, machines and really people, and in particular here the machine learning part, in this case for entity resolution. So you see here a table where like you have different products. Some of them are the same, for example, there's Apple, second generation and so on. Some of them are not, and we are trying to figure out, like with the help of the crowd and machine learning, okay, which products are really the same. So we are looking now into this like hybrid space, really merging the two together. And so if you use like the algorithms alone, here are two techniques. The green one is the similarity join techniques. The purple one, the support vector machine based on machine learning technique. You get like a certain curve between like the precision and the recall, depending on how you set certain thresholds. So what you see essentially is like the following curve here. So you can decide, okay, how much recall you want to have in your answers, how much precision. However, if you bring now people into the mix, you can bring it higher up, right? And you can get like more precision with a bigger recall, just like by including people into this whole mix. And we are currently working on techniques on how really to combine the two better together as part of CrowdDB. So it's important to adding people into the analytics lifecycle. There are like many issues in doing it: inconsistent answer quality, the incentive problem, how to do the user interfaces, and so on. But like this, inside the MPLEG, we are trying to like tackle this problem. So CrowdDB is like one of the first approaches towards this vision, and we develop like different techniques to get the handle on it. One is like statistical methods to quantify, okay, like what is the quality, how complete is the set. We're trying to figure out, okay, what are the right interfaces to achieve high quality, and this is like the CrowdDB optimizer part of it, trying to figure out, okay, what's the best interface to get like the best quality for a given question. And of course, like we are looking into this like cost-based optimizations in order to figure out, okay, like how much money should I spend, how much time to get a certain quality back. With that, I would like to conclude. So crowdsourcing can help with big data. CrowdDB is, as said, like a first attempt towards this vision. And I can really just encourage everybody just to go on Mechanical Turk and at least like do some hits and post one. Okay, thank you very much. Questions?
Time for one question.
Time for one question.
So what is the time frame on releasing the CrowdDB source code to the public?
I refer this question to Mike Franklin because I'm leaving to Brown.
We're not currently planning to do that. There's a prototype that was put together with a little spit and baling wire. If you're interested, I'm happy to talk to you and see.